Welcome. We're going to look at some examples on 8.5 using a distance formula and equation to write the quadratic equation. So here's the first one that you see here, and the directrix is y equals -4. The focus is at 2, -2. It's this green one. And we know that the distance to the focus is equal to the distance to the directrix. So in other words, the distance right here, the vertical distance, has to be equal to the distance to the focus. So we can represent those algebraically, and then we can rewrite the equation. So the vertical distance is usually the easiest. In this case, it's going to be y minus the -4 of the directrix. The distance formula is the square root of the difference of y squared. So in this case, it's y minus -2 plus the difference of the x squared. And in this case, it's x minus 2. And those two are equal based on the geometric definition. The distance to the directrix and the distance to the focus are equal, so therefore we have an equation. We can expand that by squaring both sides. So we get y plus 2 squared plus x minus 2 squared equals y plus 4 squared. All right, and I'm only going to square the y term here. Y squared plus 4y plus 4 plus x minus 2 squared equals y squared plus 8y plus 16. The reason I'm not squaring the x term is because I'm going to use that in my quadratic equation. We can eliminate some things. The first thing is y squared. We can eliminate that. And I'm going to subtract 8y from both sides. Okay, so let's see what we come up with. We've got -4y plus 4 plus x minus 2 squared is equal to 16. And we can change that to -4y is equal to the opposite of x minus 2 squared, since we're going to subtract. And that should be plus 12, since we're going to subtract 4 from both sides. So ultimately, we can write an equation of y equals, if we divide by -4, y equals x minus 2 squared over 4 minus 3. And that is our quadratic equation. I'll do one more. Here's one that is a directrix is y equals 3. The focus point is right here at 2, -1. The question is, how do you find the vertex? Remember, the vertex is always halfway from the focus to the directrix because the distance from the point to each has to be equal. So therefore, our vertex is halfway, and our vertex is at 2, 1. Now, the distance is the same. The distance from this point to the focus, I can use the distance formula. The distance from this point to the directrix, I can just do y minus 3. We'll go ahead and square both sides, and I get y plus 1 squared plus x minus 2 squared equals y minus 3 squared. Okay, I'm only going to expand the y term. Y squared plus 2y plus 1 plus x minus 2 squared is equal to y squared minus 6y plus 9. Good news, we can get rid of the y squared term. So now we can write it in an equation, and let's go ahead and do that. So over here I've got 2y plus 1 plus x minus 2 squared, and over here I've got negative 6y plus 9. I'm going to subtract or actually I'm going to add 6y to both sides. And then from there I can go ahead and solve the next step. So 2y plus 6y is 8y plus 1 plus x minus 2 squared is equal to 9. We'll subtract x minus 2 squared and subtract 1 from both sides. So that gives us 8y is equal to negative x minus 2 squared. 9 minus 1 is 8, so plus 8. Last step, divide by 8, both sides. So now we have our equation. Y equals negative x minus 2 squared over 8. 8 divided by 8 is 1, plus 1. Okay, that matches the vertex of 2, 1. When you look at our equation in vertex form, it'd be 2, 1. Question, given the focus of directrix, how do you find the vertex? Well, it's actually quite easy. It's the vertex is halfway between the directrix and the focus point. So in other words, here the vertex is going to be right there because the distance is the same. Given the focus and the vertex, how can you tell if it's up or down? Well, say this is the focus and the directrix. This one would be up. And if this is the focus and the directrix, this one would be down. How do you see the distance between the focus and the vertex showing up in the equations? Well, actually, what's pretty cool, this distance here, f minus v, is p, and also from v to there is also p, is another way to look at it. So if we look at the first one, notice that the distance was 1, okay, and therefore the coefficient is going to be 1 times 4, or 4. The distance in the next one over here is f minus v is negative 2, and so therefore negative 2 times 4 is the negative 8 coefficient here. Okay, so it's used as the coefficient, and it's actually 4 times p, and that is the denominator, believe it or not. And so as an example, this is a way to write all quadratics that are vertical, where if you figure out that p-value, you can just write the equation. If you know the vertex, hk, this has a vertex of hk, and p is the distance between the focus point and the vertex, right? Then you can use this equation. The coefficient is 1 over 4p, x minus h squared plus k. You'll notice this is in vertex form.